Right, let's have a little look at some, seeing as we were interrupted yesterday, let's have a little look at some geometric sequences. So the key thing that we talked about was, oh, something's flashing up on my computer. The key thing that we talked about was the idea now, when we're geometric, the thing we have to identify is that we've got a common ratio. So one of the simple examples I gave to you of this was 3, 6, 12, 24, for instance. And we see, well, it's obviously multiplied by 2. The question, has it multiplied by 2 again? Yes, and yes again. So it has a common ratio, and we call that common ratio R. Now, the nth term of geometric sequence was also something that we touched on, and we got this as un is equal to un is equal to the first term, u1, multiplied by r to the power of n minus 1. u1 r to the power of n minus 1. And that will get us straight to either our first term, second, third, or fourth, fifth, sixth, and so on. So that these obviously continue, and it could be any term that we target. So n would be the term it is. u1 in this instance that I've got here is going to be the 3. And so if we were going to ask a simple question, it might be something like, what is the 10th term? u10. For this sequence we've got, it would be 3 times the common ratio, which is 2, to the power of n minus 1, 10 minus 1, I'm just going to write straight in as being 9. So 3 times 2 to the power of 9. 2, 4, 8, 16, 32, 64, 1, 2, 8. Oh, I'm getting there now. 2, 5, 6, 5, 1, 2. Oh, times 3. Oh, gosh, right. I'm going to get my calculator right now. And I'm getting 1536. Okay, so that's the general idea. Now, with this information, there's some potentially different questions that we could be asked. So let's have a look at those. If I go on to the next page, I've got a question ready here for us. Second term of a geometric sequence is 4. So what I'm going to do is I'm going to write out that information. So u2 equals 4. And the fourth term is 8. u4 is equal to 8. The common ratio is positive. Find the exact values of the common ratio, first term, and the 10th term. Okay. How is this put together using our nth term? Well, 4 would be equal to u1 times r to the power of 1, or just r. And 8 would equal u1, again, times r to the power of 4 minus 1, which is 3. So we've got two equations here, first and our second. Now, we are going to solve these simultaneously, and you could rearrange and substitute. We can't subtract or add, but we can do a division. So if I do the second term divided by the second equation divided by the first, let's have a look at what I get. First of all, 8 divided by 4, 2. The u1s cancel and I get r cubed divided by r to the 1. I might write this out in full. I'm doing a lot of workings without writing it. So I get u1 r cubed divided by u1 r. And in the same way, I might just write this out in full, and we get here 8 divided by 4. So all I'm doing in each instance is this equation divided by this one. And now I can simplify. 8 divided by 4 is 2. My u1s cancel, and r cubed divided by r is r squared. So therefore, it asks for the exact value So I'm going to leave it in third form. Root 2 is equal to r. And the positive one because it's positive. So root 2 is r. Now I should be able to find the first term. So so that was part A done. B, using 4 equals u1 times r, which is root 2, I can say u1 is 4 over root 2, which I could rationalize. I may as well, mightn't I? So 4 root 2 over 2 is u1, and the 4 and 2 cancel, means I've got 2 lots of root 2. So there's part B done. And C then, the 10th term, let's go across here, just because I'm running out of space. 10th term is equal to u10 equals u1, 2 root 2, I've just worked that out, times r, root 2, to the power of n minus 1, which is 9. I'm going to put that into my calculator again. 2 root 2 times 2 root 2 times root 2 to the power of 9, and I get 64. That's my answer here. Okay, so that's one type of question you might get, setting up those simultaneous equations and solving them. Another one, this is quite interesting. The numbers 3, x, and x plus 6 form the first 3 terms of a positive geometric sequence. So it tells us that there's a geometric sequence. We don't need to identify it. Now, when we talked about geometric sequence, if I go back, when we talk about the geometric sequence, we're saying that any number divided by its previous number will equal the common ratio, whatever that is. So in this one, 6 divided by 3, that equals 2. If I try a different one, oh no, I haven't got a different colour, okay. If I did 24 divided by 12, that would equal the common ratio too. And that's the idea that I'm going to use here. So I'm going to describe my common ratio in different ways. First of all, it can be the second term divided by the first, and that will be equal to the third term divided by the second. Right, let's solve this. I get an x squared equals 3x plus 18, x squared minus 3x minus 18 equal to 0. Can we do this? Let's have a little look. 6 and 3, x minus 6, x plus 3. Yeah, happy with that. So x would equal 6 or 3. Let's have a look. Back at the question, it says it's positive here. So I'm actually going to reject one of those. Let's say so that should have been a negative 3. In which case I'm going to reject it, and we're just going to say x is equal to 6. So now we should be able to work out a little bit more. If x equals 6, remember this thing here is equal to my common ratio. So my common ratio r is 6 divided by 3, which is 2. u1, my first term, is 3. And that's everything I need to know. So now if I'm answering part B here, I can say then u10 is equal to u1 times r to the power of n minus 1. Have I done that recently? Feels like a calculation that I did earlier. 3 times 2 to the power of 9 is 1536. So u10 is equal to 1536. And there's our answer done. So that's just me going through a couple of different types of questions that we might get with geometrics. We'll have a go at some of these when I see you next. And I'm going to stop my recording.